Yes, it tells about the applications of MPLS, which is the traffic engineering. One of the unique application is traffic engineering. So RFC 2702 tells about the requirements for TE traffic engineering over MPLS. And the third one is RFC 3036, which tells about the LDP specification. What is LDP? It is the label distribution protocol. The label distribution is a unique feature in MPLS. So this documentation is also a very important documentation. And coming to this picture, it tells about the MPLS protocol in the OSI model. So we can see all the existing data link layer protocols. Along with that, the MPLS also resides in it. But this MPLS, as we have already seen, it works along with the IP protocol. So it provides connection oriented service along with the connectionless IP servers. So that is why it is called as the layer 2.5 protocol. And also you can see over here DWDM, which is dense wavelength division multiplexing. What is that? It is the most popular wavelength division multiplexing technology that is being utilized by the telecommunication and other carrier companies. So, what it performs, it combines and transmits multiple signals of different wavelength simultaneously on the same fiber. So, that's the advantage of it, and the MPLS protocol works along with it on top of it, and hence it gets the name. It's a layer 2.5 protocol. And coming to the important feature in MPLS, which is label switching. So, what is the label switching? So, our ultimate aim is to forward a packet from a source to a destination. Let us assume the source A and a destination node B. How it can be forwarded? It can be done in three ways. It can be either broadcasted. So through broadcast, you can transmit a packet. Otherwise, you can perform a source routing. So what is meant by source routing? In source routing technique, the source determines the path to reach the destination. So there is a predetermined path which the source utilizes to send the packet, or which the packet takes care, which the packet uses to reach the destination. And then the third technique is hop by hop routing. In hop by hop routing, a node chooses the next best hop towards the destination. There will not be an entire path, but it finds the next best path. So and among these thing, in hop by hop routing, so along with the packet, a label will be added by the MPLS protocol. But this kind of labeling, is it unique in MPLS? Is it available in the existing protocols also? Yes, the labeling or the identification values are present in some of the existing protocols as well. So in ATM protocol, let's say for an example, ATM protocol, it contains values called as VPI VCA, which is the virtual path identifier, VCI, virtual circuit identifier. In frame relay, there is DLCI, which is the data link control identifier, data link connection identifier. And then in X.25 protocol, LCI is there, which is logical channel identifier. And then in TDM, there is circuit identification code. And finally, what happens in Ethernet switching? The Ethernet switches switch the packets between the same VLANs. So in Ethernet switching, the VLAN ID will be there or the port numbers will be there. So these are some similarities between the labeling ideas of along with the other protocols. So this what about an MPLS? The MPLS changes the labels at every node towards the destination. So that is the unique feature. The similarity is there is labeling concept in almost all the protocols, but in MPLS the labels will be varying for every new node, and the connection between two endpoints across the IP network uses this MPLS labels to encapsulate and to transport the various data link layer formats. So that is all about the label switching. So this is the unique feature of labeling in